Hello and welcome to this lecture video. In this video I'm going to finish discussing high-low, do some extra practice problems on high-low, and then discuss least squares regression and then summarize the methods for cost estimation. So if we look back at these problems, this is what we did in some of the other lecture video. Remember, what we were assuming is we want to know what's the total cost at 700 units. And what we assumed is that our variable cost per unit stays the same and that our total fixed costs also stay the same. Remember, those are our key assumptions that we've been dealing with in this entire chapter. So if those assumptions hold true, we can figure out our total mixed cost at 700 units by multiplying the number of units times the variable cost per unit, which stays the same. This would give us our total variable costs. We know our total fixed costs stay the same at 3,000. That gives us 6,500. Same over here. At 300 units, you can see we don't have 300 units up here. We want to know what our total mixed cost will be at 300 units. 300 units times our variable cost per unit plus our fixed costs gives us our 4,500, which would be our total mixed costs at 300 units. There's a blank page there, so let's look at page 175 in terms of these quick check problems. So why don't you go ahead and pause the lecture video, do these two quick check problems, and then we'll review it together. Okay, hello and welcome back. Let's see how you did. So our first one, sales salaries and commissions are $10,000 when 80,000 units are sold and $14,000 when we sell 120,000 units. Using the high-low, what's the variable portion of sales salaries and commissions? We take our difference. We always start with a base. So we take the high base minus the low base, and then the corresponding cost with the high point minus the corresponding cost with the low point. Now in this situation, this problem's a little bit easier because we only have two data points, which are the high and the low. But anyways, we take the total, we take the difference in cost divided by the difference in the base, 10 cents per unit. Now, when we're trying to find the fixed portion, we can set it up with our y equals a plus bx. And so what we do is we either choose the high point or the low point in terms of total cost. In this case, I chose the high point. Doesn't matter if you would have chosen 10,000, you would have still gotten the same answer. So I said 14,000, which is my total mixed cost, equals my unknown a, which is my fixed cost, plus my b right over here, which is my slope, which is my variable cost per unit, times my level of activity. Therefore, I can then solve for a. It equals $2,000. Okay? The last cost estimation method is probably the most superior, or is the superior method. And that's least squares regression. So with least squares regression, what we'll be using is some mathematical formulas, or more likely you'll be using a software package such as SPSS. You could use R. You can even use Microsoft Excel to do regression. And so what regression does is it finds the line that best fits the data. Okay, so what happens is with regression, the software plots all these different data points, and it says, here's my total cost at this level of activity. Here's my total cost at this level of activity. Total cost at this level of activity, and it plots all these, and then it finds the line that best fits the data. That's what regression does. Now, when I say the line that best fits the data, it's the line that minimizes all these errors. See how we have an error right there? This is another error. This is another error. So what we want to do is find the line that minimizes all these errors. Okay? So we can find that line that minimizes the sum of all these errors. Now the problem is, this is a positive error. That's a negative error. See how that's below the line? This is above the line, so this would be positive error. You take this minus the point on the line, this minus the point on the line. You can see this is less, because this will give a negative error. Okay, so if you were to add up all these, it may not make very much sense because some of these are positive, some of these are negative. How can you get around this? By squaring the errors. Okay, by squaring the errors, by squaring it becomes positive. So what regression does, and you may have learned about this in some of your stats classes, is that regression finds the line which minimizes the sum of the squared errors. It finds the line that minimizes the sum of squares. That's what that means. Okay. Once we have that, the software, let's say Microsoft Excel, it gives you the slope and it gives you the fixed cost, which is the intercept. This is the fixed cost right there. That's my intercept. Okay. It gives me the fixed cost and it gives me the slope of the line. This is my variable cost per unit. This is my fixed cost. And then what I can do is any level of activity, I can plug in X, multiply that times the slope, put in my fixed cost, and then that gives me my total mixed cost. Regression would be the best. Okay, regression would be the best. And like I said, you don't need to do regression by hand, although I have done it by hand. It's been a long time, but I have had to do it by hand in stats classes. I would never do it by hand now. I would use SPSS, R, or even Microsoft Excel, okay, to do my regression. Now, when we talk about comparing results from these three different methods, all the methods provide slightly different estimates of fixed and variable cost. Okay, it's because they, for example, account analysis uses judgment, versus regression takes a more scientific approach, and so it can give you some different estimates of variable and fixed costs. Okay, least squares regression would be the best. All three methods, cross that out, all four methods require linearity, requires us to assume a constant slope. Now, the problem with the high-low, right, is that it only uses 2 data points, versus regression uses all the data points. High-low only uses 2 data points, and the other problem is with high-low is the 2 data points that it uses are the high and the low, which are atypical. So you're using the high and the low, which are the atypical data points, to estimate an average slope or an average variable cost per unit. So it doesn't really make very much sense. Okay, so those are some criticisms of the high-low. I guess maybe a benefit for the high-low is that it's easy to do. But frankly, I would use least squares regression, especially because it can be done in Microsoft Excel, and it's pretty easy to do in Microsoft Excel. If you take my accounting information systems class, which is an upper level accounting class that I teach at Mary Washington, I go into detail on how to do least squares regression in Microsoft Excel. All right, so that's the end of this lecture video. In the next lecture video, I'm going to go ahead and introduce cost, volume, profit analysis in a little bit more detail, and then also discuss our contribution income statement. Okay, thanks so much.